Hi everyone, can you hear me all right? Yep, cool. So today we'll be speaking, as the title suggests, about methods of lateral movement in Windows OpenSSH. So first off, who am I? Matt Lucas. I realise that's a very UK-centric joke for a Swedish conference, but Bake Off is good. I'm a security consultant at WithSecure. I generally like to hack all things kind of Active Directory, all its individual fun components, and I kind of dabble in Azure as well. So basically, my happy place is screwing around with things Microsoft has made. I'm going to be speaking today about Windows OpenSSH, and yes, specifically OpenSSH. Microsoft and the open source community have created a full-blown port of the actual OG, like OpenSSH repo, basically for Windows. A lot of people still don't realize this, right? You don't need to install PuTTY anymore unless for some reason you really like it. If any Windows 10 or 11 device now, if you open up your laptop, do SSH -- version, there's going to be a client installed there. There's also a server-side component, which you have to manually install, but there's a nice shiny version for you on like PowerShell Gallery and everything. So if you've ever kind of gone through the full list of like supported authentication methods in OpenSSH, like OG Linux, you'll know that there's this giant, huge list, far longer than anything that anyone actually uses. Microsoft and, as I say, the open source community have so far just ported over kind of the three that anyone ever seems to use, i.e. password, public key authentication, and sneakily GSS API authentication, which I'm going to use interchangeably with Kerberos authentication for this talk. Those of you who watched the DEF CON talks this year know that there was a recent fun vulnerability in GSS API authentication for Linux OpenSSH. I won't go into too much detail here for time, but I've had a little poke that fortunately Windows doesn't seem to be vulnerable to that exact thing before you get too excited. As you can probably guess kind of from the title of the talk and the fact that I've launched straight into authentication methods, this is basically going to be the crux of where kind of lateral movement vectors arise. And a lot of them are going to basically be more or less rehashes of the ones that we already know in Active Directory, but with a few kind of OpenSSH quirks. So just super high level, if you've got one server, you've installed OpenSSH server on it, and you're one computer, and you want to authenticate to it, you go to it, you say, hey, I'm me, here's my password, my cryptographically signed whatever to prove who I am. The server does both the authentication and the authorization check then. So it will say if your password, whatever, is correct, and it will check its access control list to decide if you're allowed in. When you add in Active Directory, this gets a little more subtle, I suppose, and this is where a lot of the kind of confusions with OpenSSH comes, or really the vulnerabilities, the opportunities for misconfiguration. Essentially, when you've got one server, it handles both authentication and access control, and you kind of, as someone setting this up, don't have to worry too much about like both. But when you introduce Active Directory, you now have an external identity provider that is checked against. And kind of the way it checks against this isn't always like the best way, pretty much. A lot of what we're going to discuss, and I'm sure you'll be able to spot which bits are also going to be applicable when you plug Linux into Active Directory too, and let SSH use that. So we're going to start with just a quick overview of kind of how the different authentication schemes work, super high level. If you're using password authentication and you've plugged in Active Directory, then instead of just having one server that you give your creds to and that's it, you start by connecting to the server, you give it your password, it then goes to Active Directory on your behalf and checks your password for you. And then Active Directory comes back to it and says yes or no, that's the right password. At which point, the server makes its access control decisions. Public key authentication is pretty well unchanged. You speak to the server, you prove that you own the private key for which it knows your public key. And behind the scenes, there's a little bit of chatting with AD, getting a non-forwardable ticket seemingly as some sort of bookkeeping process, but it's not anything that's sort of super important, basically. Feel free to prove me wrong on that, you pesky hackers. And then Kerberos authentication is just the standard Kerberos authentication flow that anything that uses Kerberos uses. You go to Active Directory, you say, hey, I've got this TGT that you gave me earlier, proves I'm me, give me a TGS for that SSH service, and you get it. The specific SPN that is used for SSH is it's the host / FQDN of the server thingy. There's not like a specific SPN that gets created for SSH. So to explore the ways in which these 3 authentication schemes can kind of go wrong, we're going to talk through a fictional attack path from a fictional company called Radiance. They are huge fans and adopters of SSH. They loved it on Linux, so as soon as they knew there was a native port for Windows, they plugged it straight in. One of their users, Kaladin, has just been phished. Your favorite Privesc vector, whatever it was vulnerable on his machine, and now the attacker has both his NT hash and a foothold on the Radiance network. But can we use an NT hash? None of those authentication schemes seem to really play with NT hashes. With password authentication, the server speaking to AD for you, there's probably some NT stuff going on there, but none of the stuff you're doing is NT hash specific. Indeed, password authentication, it needs a password, not the hash. Key authentication needs a key, no surprise there. Kerberos authentication, though, we can kind of get away with that in certain situations. This isn't a super new technique, right? This is something called overpass the hash. Essentially, in scenarios where requesting Kerberos tickets with NTLM hashes enabled, you can pretty much go straight back to more or less passing the hash, even in things that support Kerberos rather than NTLM directly. So just as a super simple demo, the play button will appear for me. Ooh, I love PowerPoint online. All right, whatever. So I'll just tell you what's in the demo because oh, there you go. So there's our friend's NT hash, one that I made earlier. The process of getting the TGT is as simple as in packet get TGT with the hash, which if that's supported will work. Set your KLB5C cache variable if you're using Linux, do some other stuff if you're using Windows to where that's stored, and then you just chuck in SSH with a -K flag, assuming you've in the background configured, GSS authentication, yes. You've got DNS working properly for this DNS thing to work, your clocks are synced, all that wonderful stuff. You just chuck in a -K flag, and in you go. So I've run here, you'll note whoami/groups. That's intentional, just to kind of highlight just a minor interesting point that if the user that you're authenticating as has administrator access to the server, it's always available. You're immediate into a high integrity session. I mean, this kind of makes sense, right? How are you going to pop up a UAC prompt in SSH? But just something to be aware of. So we've been through Kerberos authentication. It's pretty simple. It's not really anything super profound and new. Let's have a look at password authentication. So just a quick refresher. You give the server your password. It chats to AD for you, and AD tells it if you're who you say you are. But what do processes on the server then actually see? Well, funnily enough, this does actually leave an NT hash sitting in memory, which is why I think it's that's probably actually what it's passing to Active Directory. The server's like creating an NT hash out of your password and passing it on. But in order to do that, it also has to at some point see your clear text password. It's making like an encrypted network tunnel when you initiate kind of this whole authentication process. But within that tunnel is just your password, right? If a Linux client doesn't know how to make an NT hash, why would it? And just to demonstrate there that yes, indeed, you do leave an NT hash in memory, in LSASS memory, if you authenticate this way. What this means is that if we're in a position where we can watch the Windows APIs, we can recover clear text passwords. Now, this is an upgrade from the scenario where we're just stealing NT hashes from memory, right? If we pop a server that a bunch of different admins are logging into, RDP or whatever, we can only really recover hashes if we're not doing some clever keyloggy stuff. But now, if they're logging in with password authentication and we have admin on the server, if we're watching that API, that multi-byte to wide-char API, we can see passwords. No prize for guessing that in this scenario where, just for simplicity, that's a local user rock, their password there, air6 lowlanders 123, yeah, it just goes through that API, that Windows API. So a very, very similar technique was weaponized before in, I believe, NDSEC's research, a tool called RDP thief. Essentially, this is kind of exploring the opposite scenario where you've compromised some users' like client machine, and you hook the APIs that the RDP, the mstsc.exe client is using. So you as a little bug there. Listen in whenever an authentication like request is made by the mstsc.exe client, and just it spits out to a file. The reason why I wanted to call out the RDP thief specifically is because essentially the SSH version, the easiest way to get an SSH version is to just steal their code and swap the APIs you're listening in on. So instead of being on the client, we're sitting on the server, and we're just listening in to what comes through that those APIs instead. Obviously, yes, you can engineer this yourself with detours, NT, whatever it is. But hey, RDP thief did all the work for us already. Hey. Okay, but then how do you actually get from one to the other? Like I said, you just swap what API you're listening into. So in this splash of crappy code, we've got, we're importing like the original multi-byte to wide-char API, creating our new one that basically just calls it, outputs that LP wide-char string variable to something else that, again, gets written to a file with the right credentials, function. And all the difficult stuff of that is done for us by detours. Yay. But how do we actually weaponize this? So if you ever used RDP thief, you'll know that kind of the default way that's talked about in the repo is to basically use a Cobalt Strike aggressor script that listens for or waits for mstsc.exe, so that's RDP client processes to spawn, and then inject a DLL into them. For my money, I think the simpler way to do it in this instance is to do something called DLL, search order hijacking. So essentially, the sshd.exe process that lives in C, Windows System 32, OpenSSH, sshd.exe, will try and reach DLLs that don't exist. If we have admin on a box, we can make them exist, and we can put whatever we want in them. Again, not a super profound, not a super new technique, but still something that's super useful. And we can use wonderful tools like netclone to basically make sure that when we put our malicious DLL in that directory, SSHD can still find the functions that it's looking for. We don't just break it and then get no creds because no one can use it. So, quick and simple demo again. There we go. So just proving nothing in seektemp. Oh, I wonder what directory creds are going to end up in. Nothing funny in C, Windows System 32, OpenSSH, just sshd.exe, etc. And we're going to SCP across our SSH user env DIL. Now, SCP here is going to use our Kerberos authentication from earlier with no fuss. If your DNS is fine, your kerb5.conf is fine, it'll just use it. Yada, yada, yada. And across it goes. And because we saw that Kaladin was an administrator on this server, this camp management server, it quite happily just put our pre-prepared userenv.dil into that C Windows System 32 OpenSSH folder. ITO. Come on. All right, and then we wait a little bit, maybe a user's going to log in, maybe they're not. SCP back across the file that contains the lovely, lovely creds, and just cat it. The reason why I'm catting it instead of grepping it is because there's some funny character set business going on that I haven't yet properly sorted out. But if you scroll up and down like a silly sausage and probably go past the password a couple times, there we go. We can see that when the user Dalinar logged into the server with pass authentication, we got their domain password, ilovehonor123, easy peasy. So, again, it hates changing slides when there's a video on screen. Wonderful. Probably Microsoft's revenge. All right, so what about the SSH client? All this talk has been on the SSH server, but just as a quick side note, can we do the same sort of stuff there? Well, if we want to sniff creds on the server, we need to listen in on the multi-byte to wide char API. Can anyone possibly guess what API you got to listen in on the client? Anyone? Wide chart to multi-byte, easy peasy. Exactly. It does it one character at a time. You can also use this API basically as a keylogger as well. It will just output everything that the user is typing. So again, kind of mega loud. You have the benefit that at least you're just listening on this API for that specific process, not the whole system. But still should be quite handy. And again, SSH client.exe or SSH.exe also tries to call to DLLs that quite simply don't exist, which is useful. But anyway, so we've been through those two authentication schemes, password and Kerberos. Key authentication, we've kind of hushed right past because the main interesting vulnerabilities there are basically the same as the Linux ones, right? Protect your keys, put a password on them. If the password is, if you put a password on, don't make a crap one. Easy peasy. Those are slightly more interesting. But where I think it gets really interesting in SSH and where I've kind of seen more valuable impact in actual engagements has been really around the access controls, and in particular, the default configuration access controls. So essentially, access controls in SSH are configured through the sshd config file. Same as in Linux, just the location is different, right? So you define things like allow users Caledon, and oh, surprise, surprise, that user can get in. Allow groups, same thing. Deny users, deny groups. Nothing weird going on there. If anything is declared in these access control lists, then that's what's followed, and everything else is blocked. So say you got to this point where you just put in allow users Caledon, Dalinar couldn't log in. Because he's not on the list. But if nothing's declared, then effectively that means you've got no access controls, and anything with valid authentication can log in, which, I mean, if you're one server, like the old, classic, you've got one Linux SSH server, I mean, that's usually not a problem, right? Because why would you make a local user if they couldn't get in? But I think you can probably guess where this might be going, why this is a bit of an issue in Windows and really Active Directory environments. In fact, not even Windows specific, Active Directory specific. Yada, yada, yada. So if AD is not in play, then, and you haven't defined anything, then user Dalinar gives server its password. If it's valid, it says, cool, I recognize you, you're a local user, I haven't been told to do anything else, come on in. Which again, why would you make a local user if they weren't supposed to log in? I know there's many reasons, but yada yada. But what if Active Directory is in play? Well, you say to the server, hi, I'm me, here's my password. It says to Active Directory, is this user's password? Active Directory says yes. And then, the server's not been told who to let in and who not to let in, so I guess you're in. Yeah, as I said, I imagine so a lot of you can kind of see what the issue is here. If you just go and install right now, OpenSSH server from PowerShell Gallery or whatever, and don't configure it in any way, and you're in Active Directory, then any user can do this and just SSH into your machine, easy peasy. But luckily, no one would do that, right? And then just an example, so if you're in the situation that we were just in, where suddenly you've got plain text credentials of a domain user, who cares who, just chuck it in crap map exec, easy peasy. And the size of this list is only going to be limited by how much money I wanted to give my cloud provider for the size of my lab. But I've seen much bigger lists than this light up. Okay. Right, so defending OpenSSH. How do we do it? So I wanted to first kind of go through what the pros and cons were of these authentication schemes, like from the perspective of someone wanting to actually set up SSH, defend it, use it properly in a Windows AD environment. So password authentication, kind of the pros are obvious, right? Everyone knows how to type a password in. And, you know, okay, not being able to pass the hash is actually a pro, you know, or overpass the hash in this instance. But of course, you know, plenty of cons with this one. Your creds are exposed to Windows APIs, an admin can steal them. Empty hashes in memory, for some reason, you know, stealing the plain text stuff is an option. And I guess technically there's the old school concern why people were already swapping from password auth to key auth, which is your local accounts are, you know, technically more brute forceable. Key authentication, this is kind of, biggest pro for me really is that this is kind of familiar as like a relatively secure option. You can configure it pretty securely as, I mean, as evidenced by the fact I didn't have an interesting attack path to show you today. You know, same pros as before around brute forcing. One of the neat things as well is that if you want to use key auth for an admin account, Windows forces you to have like decent file permissions on the administrator authorized keys folders, files rather, meaning that you can't just use this as a really stupid easy privilege vector. SSH just won't work if you set it up that way. And of course, there's nothing interesting that leaves in memory because you're not putting your domain creds in. You're using a public key, which is, you know, a different thing. And then the cons again. It's the important ones are the same ones as Linux. Don't leave your keys in stupid places. Put a decent password on them. And then Kerberos authentication. I put both the pro and the con as most natural integration with AD. Anyone who's kind of hacked AD environments can, you know, appreciate that. But you know, more seriously, there's no. This doesn't seem to leave any sort of interesting, useful stuff in memory that you can go and like, you know, pop the rest of the environment with. Is vulnerable to overpass the hash and pass the key, and it doesn't seem to be vulnerable to that recent GSS API phone that dropped at DEF CON this year. And yeah, I mean, by integrating with AD, it's the most kind of centrally manageable users, as in the users are the most centrally manageable out of all of them, really. And then kind of after all of this stuff I've talked about, you know, opening these massive holes and what have you, and bringing in these kind of familiar techniques in a new context, what, like, should you actually use Windows OpenSSH? On the pro side, I would say there is a genuine benefit to being able to administer both your Windows and your Linux estate with one tool, right? Complexity brings security whole, so having it all under one thing is an actual useful thing, and I think for security too. The default configuration being horribly insecure is depressing, especially since you can't stop your, I mean, I'm sure with like proxy controls and what have you, but in general, you can't stop your server admins from just opening up PowerShell, running, you know, add Windows capability, OpenSSH server. Yeah, back on the pros, it is easy to use, which is good. But back on the cons. Yeah, the way that you configure it through this SSH config file, it makes your life hard to actually enforce like a centralized good config, right? If it was like registry keys or something, you could use group policy to easily just, you know, set good ones throughout. But it being some set of files, it just inherently makes it a bit difficult. It's not impossible, just not kind of natively easy, which makes that last pro harder to achieve, which is that, you know, okay, yeah, you can configure this securely, but your life is just harder in doing so, or at least forcing your whole estate to do so. Just on the point about kind of group policy and just the point about centralized management in general. Really, all the things that group policy specifically offers you, at least so far as I've dug about, is pretty much to restrict it entirely, which is a bit boring, or you can technically push a known good SSH config file across the place, but then you kind of have this one-size-fits-all issue. The preferred method I would suggest would be to try and get in during the provisioning of your servers. And basically, from the start, introduce a known good SSH config file, during your CCM task sequences, your golden image provisioning, whatever it is. So the first step of that being choose the authentication method that you want, that your environment is best suited to deal with securely. And then in whatever way you provision it, as an example, PowerShell, add in, yes, do use the authentication methods I like. No, don't use the ones I don't like. And then make sure that there's some sort of access control list that you're happy with, right? So in this example, I've chucked in just allow groups, your domain / your host -SSH or some local SSH groups. Basically, either a domain group or a local group. Pros of domain group, you can centrally manage it. Cons of domain group, an attacker can enumerate it. Up to you to weigh up, basically. To be honest, I'm not quite sure why something like the local SSH thing that I've put there isn't by default right. When you install remote desktop on a Windows machine, it creates a remote desktop users group, and that's who's allowed in. I don't really see why that's not the default for SSH, but anyway. Okay, right, on to some detection points. The detection points, I'll be honest, aren't super useful or super incredible in this scenario, basically because it's the age-old question, how do you distinguish between legitimate use of a remote access tool and lateral movement, right? It's all context. Kerberos, if someone's doing this over past the hash technique, you can use the standard detection for over past the hash, which is if your environment is all AES tickets or AES-based Kerberos tickets, and just one thing's using RC4, then hey, maybe that's something dodgy, or maybe it's just one of your apps misbehaving. It's the woes of detection. Password authentication, there is something, it's a little bit more clear-cut, but still very much environment dependent. Specifically, there are some artifacts left behind by someone doing that crap Mac exec thing that I showed earlier, basically taking all your domain that has SSH exposed and just trying it. One, you create, a C user's username directory by default if you successfully log in. And two, you cause a logon event of type 8, which, if you can read there, is network clear text, which is very weird for my money. I'm sure there are some legitimate uses that me, as someone who breaks things rather than makes things, hasn't considered, but that's weird. Obviously, the reason behind the name being it's a network logon, but Windows receives the credentials in as far as it views clear text. Obviously, it's for an encrypted SSH channel, but by the time Windows is processing, that's already happened. Other than that, I'm sure there's cleverer things you can do to detect things like the API hooking in the SSH thief example I've given. But in general, I think the most powerful tool for this stuff is basically baseline your environment and just are people doing weird things like, I don't know, some user who's never used SSH in his life, suddenly SSH into your prod DB. Weird. Okay, so just final word from me. So I haven't seen super widespread adoption of Windows OpenSSH. Yes, the client is installed on all your machines already, but the server I've only seen used in kind of a few environments. But when it is present, it's very common for it to be set up in the dangerous default. And you may have noticed, if you're nerdy enough, that the whole naming scheme of this has been Stormlight Archive, but please, I'm only halfway through book 3, so no spoilers, thanks. Okay, and that's me. Thank you very much. All right.
Cool. Okay, do we have any questions?
to go over
one
them.
more.
Yeah.
So I'm curious about the way you are recommending configure SSH with the configuration file. Pretty much any modern version of OpenSSH allows you to include an external file instead. Shouldn't that be an easier way to distribute the configuration?
Sorry, go again. What was the better solution you were suggesting?
You can use an include directive and then just include whatever configuration file you are distributing over the Active Directory or, for example, over Samba.
Yeah, that sounds pretty good to me. Let's speak afterwards. I think that sounds like a good idea.
Thanks for the great talk. Just wanted to thank you for including some hints to forensic analysts in your talk. That just wanted to say thank you for that.
No worries. Yeah, that is a personal point of mine. I think it's cruel for us to release attacker techniques and just leave the good guys out in the cold. Yeah, sorry that they're not any better, basically.
Okay, thank you so much.
All right, thank you.